Thanks to all of you who are joining us today. I'm Taryn Jones, part of the developer marketing team here at Kong, and I'd like to welcome you to our February Kong Gateway user call. Today we have a special presentation for you from Wangchong Zhao, a senior engineer at Kong. Wangchong is going to talk about the recent Kong Gateway performance enhancements and tell you how he and his team were able to obtain a 12% increase in RPS and a 37% drop in latency. At the end of the presentation, we will open it up for Q&A and discussion. You'll be able to unmute and turn on your video, but you can also feel free to drop questions in the chat tab at the bottom of your screen, and we'll make sure and get to those. So with that, I'll go ahead and hand it over to Wangchong to start the presentation.
Hello everyone, my name is Wangchong and I'm a team gateway engineer working at Kong. So first of all, I want to say Happy Tiger New Year to everyone. And as you know, Tiger runs very fast. So the topic we are doing today is also about speed, which is about the recent performance gain we have in Kong. We are going to share the journey on how do we find the issue and how do we solve it, and also the technical background around this topic, and hopefully this will benefit to all of us about learning Kong and also OpenResty. Okay, so before we get to the technical part, in case you didn't join our previous meetups, we do introduce our performance testing framework a while ago. So this framework is currently open source. It will going to be in enterprise as well in the next version. This is basically some extension to our current Lua-based end-to-end testing framework. You can run multiple backends from Docker to local machine to Terraform provisioned real bare metal machines. And it will give you results like IPS and also as well as frame graphs. So we can give you like a brief idea of how it looks like. So it's just written in Lua, and you can call multiple APIs, like start this script to collect the system tab samples, and then start the load and gathering the results. Okay, so we do have a integration of this framework with our GitHub CI, so you can view all the results here and also download the artifacts, which includes we so-called the frame graphs. Okay, let's take a look at what a frame graph looks like. So it got its name from its shape, because it looks like a flame being set up, and the span of each of these box represents the time it takes when it's being sampled. So the system tab is a kernel module, so it will sample the call stack of the current process, and it will record what is the current function being called, and as well as its parent call stack. So so the longer the span it appears in the frame in this frame graph, it means CPU is taking more time in this function. And this is a test case we have for 10 services, 10 routes, and no plugins. So basically all the Kong core itself. As you can see here, kind of obvious that we have this var get var set taking a lot of time. It's almost like 20% of time. You can also actually see this appear in other phases. So yeah, that's how we get to the idea on what part should we optimize most. But of course, the part it takes most does not mean it's always slow. It's probably also doing some business logic, and you cannot always optimize. But we decided to take a look on how much can we improve on this part. Okay, so in order to optimize it, we first have to understand how it works. Okay, so let's take a look and first take a look at what is a variable. What is a var get var set? What is being getting in the setting? So uh, the residual corridor var get is an OpenResty API for accessing so-called nginx variable. The nginx variable, uh, if you define it in the configuration, it will start with a dollar sign. So the set is a special directive provided by the rewrite module. So it allows you to define a variable and also set its initial value. So for example, this conf proxy mode is initialized by the set directive, and it has initial value of HTTP. Then in OpenResty, which conf is built upon, we have this nginx.var.conf to access this variable. You can also use the same syntax to set its value. For example, you can say var.conf equals to, for example, gRPC. Then you are setting this variable to a new value. Okay, so uh, so this API is provided by OpenResty, and how it's being accessed. Let's get to the initial part. So here we are patching this in engines.var to redirect its like a getter and setter to a new function, which here is var get. Okay, then let's search for this function. Let's start some sanity test and prepare the buff and all the stuff, and then it will call this function. Okay, this is called through we call it FFI function. So FFI is a special technique LuaJIT provides, and also it appears in also other languages to give you the bridge to call a C function from Lua side, and also it provides you a automatic translation from Lua types to C types. Okay, so it calls this C function, and let's go above and see what it does. So this function is equals to this guy. So inject HTTP Lua FFI varget. So this is actually a C function, but we're calling it from Lua side, so we need to go to the C source code and see what it's been doing inside of it. Okay, let's search for this function. Okay, let's take a look. Okay, so this is the sanity test. Okay, so it accepts several parameters. So this is the request context, and also the name data, which is the key of the variable you're getting. It appears in two variables, which first one is the deterministic string, and also the length. And then you're getting the buff to let the process do anything, and also the value to return. Okay, so if name equals to 0, this is a special case. Let's go back to here. So this is about a different call path, which is the regist capture groups. We're not touching that part, so we will just ignore that here as a comment describes. Okay, so it's for a normal key variable like this guy we were talking about before. It will hit this path here. So it ultimately will call the nginx hash function to calculate its hash in this hash map. So we're passing some buffer to allow the calculation, and also the input named the key itself. Okay, then we call this function called nginx HTTP get variable, which will pass in the hash, and then it will return you the value. Okay, this is how it does in the current world before we have this optimized. Okay, this looks very straightforward, and you normally you would see any sign of why it's being slow, and or why should we do it in the other way. But let's hold that on for a second, and let's actually take a look at what other people are doing, okay, what other modules are doing. Okay, so let's take this simple module, for example, which is a memcached module. It's part of the official Nginx release. So in this module, it creates a new variable called memcached key. Okay, so this is sorry, this is defining this string, and let's see how it's being used here in this module. Okay, so in this function we call it memcatch pass, which is a directive handler. If you search above, okay, so this is the handler for this memcached pass directive in the nginx conf. It will automatically call this function with appropriate configuration you have in this conf nginx.conf. Then you'll notice this line 7 to 8. It calls nginxb get variable index. Okay, so and it's passing this the string literal, and it's storing this index into its module context struct. Okay, let's see how it's being used actually. So let's search for this guy. Okay, so in this function, memcached create request, which as is stressed, is being called in every request comes in. When nginx create the request context. Okay, so you notice in 250 this line is using a different function. It's called HTTP get index variable. So if we go back, there's a difference of index and non-index. So if it's in the OpenResty part, we're doing nginx get variable, which we pass in the hash, which we're actually doing a hash map lookup, and in here we're just passing this index. Okay, so as the name suggested, it's doing an index lookup, which is just using the array index to find it. Okay, so now the question comes: why OpenResty choose the other way, not this index way of doing things? Okay, so let's search for what other people are doing. Are using this function. So whether it's fast or slow, it appears in the Nginx API, then it has a reason. Otherwise, you just got deleted. Uh, there's no reason to have two functions with different API that does exactly the same thing. Okay, so if you search for what variables are using this function, instead of the inspection from the part that defines this variable, we have used it in the per module and also the SSI module. So if you read the documentation of the SSI module and the per module, you will notice that both of the two modules is kind of allows you to do the dynamic scripting. So per module, of course, allows you to run Perl scripts. It's similar to OpenResty, but its main programming languages is Perl instead of Lua. So it will also allows you to get variable, set variable. This server side include function also has its simple DSL of writing a script to allows you to execute certain logic. So let's also search for get index variable. Okay, this will appear in more modules, which say this user ID filter maybe get in. Okay, so this all no, let's search for this resetting. Let's search for how the index is being get. Okay, so this function, if you search for the caller, which does get the index and initialize this index, is being called it's actually been called in the configuration phase. So now the answer becomes kind of clear. So as long as a variable can be deterministic during the config time, this config time we're referring to the nginx.conf time. So when you load this configuration into nginx, this does not include any dynamic programming part. So as long as you can know which variable you need uh, during the configuration time, then you can use this get index variable API to preload its index, and then in the request during the request time you can use index to access the variable. But however, if you cannot know which variable you need, it's especially happen when you are accepting a script to execute during a request, then you will not know uh, which variable you need during the request. Uh, then you don't then you don't then you will have to use the get variable function instead of the index one to access the variable. Okay, so understanding this part, let's go to the sorry. After understanding this part, let's get to next section, which is how do we improve the performance of this var get and set API. Okay, so we build a new module, new function into our current module called Lua Kong Nginx module. It does some patches and also provide us new APIs to use in Kong. Like we have for the RSD core, we are also having a patch of the nginx.var table to redirect its core to our new function. So this is a getter of this meta table, and it's redirected to var get by index. Before we search for this part, let's take a look at the logic here. So we have this variable index, which is a name to index map in Lua land. If the index is found, we can just pass in the index to find the variable. Otherwise, we'll fall back to the original get, which provided by the official OpenRST. And this function will call this API. We'll call this function in CLand, which is also an FFI interface we built in this module. Let's search for this module. Actually, it shows me my history. Okay. To see that the same, we do some sanity test. And hey, so for here, so we now use the new API we found, which is the indexed access variable function. We're just passing in this index to get the value back. And it also the same for set, but set is more complex because you have to handle non-existence and all the special cases. So we'll not cover this part in this meetup video. So now you're going to ask a question about how do we know the index of a variable, right? So we are having two different functions. The first one is to tell Nginx to index a variable you specify. Okay, so the load var index is a handler for a new directive called load var index, Lua Kong load var index. So if you type this one and also, for example, Kong proxy mode, then it tells Nginx to index this variable. Okay, so if we go back to the function itself. Okay, so it calls the get variable index as we see in the memcache module, and it returns this index, but we're not populating this to the caller. So actually, if you search for this function, uh, variable. Actually, aside of giving you the index, it will also handle initialization for you. So, for example, if this variable is not previously indexed, it will push the value into this index, and if it's being already found, then it will just return this value, return this index. Okay, so we're actually doing this. So this function just for here, we're just using this logic to tell Nginx to index a variable, but we're not getting the result back. So we have a different function called loading indexes. This is a FFI interface we will use in the Lua part, and for this function, we're returning all the indexes of the names we want for the variables. So it actually just iterates over the index, the array index, and gives you back the names. So it returns the names in order, so you don't need to instead of returning the maps itself. So if, for example, if com proxy mode appears in the first of the array, then its index is always 0. Yeah, so it's a small trick we're doing here. Yeah, so yeah, I guess that's all the technical part we have. So let's also show the uh, results we have after we have this other stuff being deployed into Kong. So in 2.6, we have this optimization. Let's compare to 2.5, which we have. So if you focus on Kong access, previously the var get and set part is like this width. See, I'm going to Kong access, right? Kong access, yeah. And you'll see it's like shorter. So get is probably still longer. This is very short. It does not even hold the rest history. Yeah. But of course, this is combined with our other optimizations of reducing the unnecessary variables and also cleaning up some redundant logic in our PDK. Yeah. So there's of course some future improvements we can get. So if we go back to this part, so there's like index, there's still a meta table lookup happening here. So if you still look at this flame graph, you will notice something happening about tables. Sorry, about index, like this one. So we can further optimize those two APIs by providing a more like a direct API call. For example, instead of doing engines of the var dot something equals to a something like this, we can do engines of the var dot set something a. This of course changed the original API interface compared to the Bernstein one, so we're not pushing that in the first release. But this will get us rid of the meta table lookup, and so just convert into a direct function call and what invokes the FFI interface. Okay, I guess that's all of it. Thanks everyone for watching.
Thank you so much, Wangchong, for that great presentation. I hope you all enjoyed it. Remember that we have these user calls once a month on the second Tuesday of every month, so we hope to see you next month. We will be talking about the new KIC or Kubernetes Ingress Controller release, so we hope to see you there. Have a great day. See you soon.